Hello, Rajat.
No voice is coming. I guess he's not able to hear you.
No, he has joined and I have made him presenter. Rajat, can you hear me?
Yes, I can.
Yeah. Now I have made you presenter.
Okay.
So before you start, let me introduce you, Dr. Rama ma'am. She is assistant professor in biotech department, and she'll be moderating this session.
Okay.
Hello, sir.
Yeah.
Hello, Dr. Roma.
Over to
Hello.
you, Rama ma'am.
So, this is the last session for the day, and I would like to introduce you all to Dr. Rajid Pandey. Dr. Rajid Pandey, he did his PhD in biotechnology from IIT Guwahati and University of Lisbon, Portugal, and 2 years of postdoctoral experience with the specialization in bioprocess and metabolic engineering. He is actually an innovation consultant at Nordic Innovators PS, where he advises highly innovative SMEs, the large companies, and research consortiums on obtaining funding from European Union, private investors, European investment banks, and European investment funds. He is also have 3 years of industrial research experience, where he was involved in R&D projects in the field of protein sequence-based drug discovery, and he is a lead author and co-author of more than 10 peer-reviewed conference and journal papers, and he has a successful list of clients where he is working with the departments of RD and I in various business technical domains, including IT, IoT, gaming, medical device, robotics, brewery, automobile, industrial data analytics. So this was a brief introduction about Dr. Rajit Pandey, and I would like to invite you, sir, to please deliver your talk. Over to you, sir.
Hello. Good morning to all of you. As Dr. Roma most kindly introduced me, my name is Rajat Pandey, and I would like to give a bit more of info about my current job, what I am doing here. I know you all must be wondering why 12 after years of research career, this guy decided to switch the job. So presently, what I'm doing is, as rightly said by Dr. Roma, I advise companies on getting funds from European Union and other private and equity investors. And these companies I help, they are highly innovative. They have their own IP, and now they are looking to break into the market. And for that, they need money. And the money is given by European Union. Mostly our bulk of the projects come from European Union. If you are aware of, if you are listening to the news about European Union, recently they have approved this new framework program for the next 7 years, which is called as Horizon Europe, with a budget of close to 100 billion euros. It's it's a big amount, and that's why the SMEs, the culture of startups and the innovative companies is growing so much in the Europe, because they are providing money to do the research. Of course, I have plans as an Indian. I want India to thrive. I want India to go ahead and learn from our Western counterparts. And that's why I have decided to deliver this talk today, to make you aware about the most cutting edge innovative SMEs of Europe, which are working in the sustainable waste management practices. So let's start the presentation without any further ado. If you can see my screen. Vikas, can you please confirm if you see my screen?
Yes, sir, it's visible.
Okay, very good. So the title of my talk is Entrepreneurship Opportunities in Sustainable Waste Management Practices. As I have already introduced myself, there is no need to do it again. Today, I am going to present 5 case studies. These case studies come from 5 different companies, 5 different innovative companies, which were my clients in the past. I was involved with them directly or indirectly in getting them funding. Some of them got funded, some of them not. So it doesn't mean that who doesn't got funded are not innovative enough. It's just that the success factor is so low. Out of 4,500 applications, only 36 get funded. So you can get an idea, a very clear idea that it's a highly competitive programs we are talking about here. But still, these companies are at their edge, at the edge of the innovation. They have moved beyond the state of the art. What is the current state of the art in their respective fields? They have moved beyond that. And that's why I have taken these 5 case studies belonging to different 5 categories of waste. As you can see, plastic, water, end-of-life tires, aquaculture waste, and industrial heat waste. I will start with the plastic waste category. So as we all know, plastic is the biggest polluting factor on our planet. I'm not going to bore you with numbers that, of course, there will be some numbers to highlight, to show the depth of the problem. But plastic, as we all know, it's a huge problem on our planet. And what we can do to deal with it. Of course, as you all know, unless we come up with a technology where plastic becomes biodegradable, we have to deal with this problem. So the best way is to do a proper recycling, a proper sorting, but that doesn't always happen. So I'll move to my next slide and show you the problem. The problem is the plastic waste and the associated sorting and recycling challenges. The numbers which are given here are the numbers from Europe. In 2018, European plastic industry produced 51 metric ton of plastic, a trend which is not slowing down, it's increasing. Out of this 51.2 metric ton of plastic, 17.8, only 17.8 was collected as waste. And out of this 17.8, 42% was recycled, 39% was incinerated, and 19% went to the landfills. Only the first, that is the recycling, is the option of choice. Incineration creates pollution. Landfill creates pollution. Our aim should be to increase recycling while reducing incineration and landfills. If we talk about this image, this is the image of classification of plastics in the municipal waste in Copenhagen, the city where I'm living in as of now. In Copenhagen, food plastic represents 45% of all plastic waste. Why I'm talking about food plastic, it will be clear to you in a couple of minutes. First of all, as you can see here in this image, food trays and tubs, they constituted 34%, food bottles constituted 11%. So total, it became 45% of the entire plastic waste of the entire city. Recycling, why we are emphasizing a lot on the recycling. Recycling ensures that food plastic is recycled back into food grade plastic. I assume you don't want to be eating in a tray which was part of a dangerous chemical barrel in its previous life. Just let me know if I'm wrong. Nobody wants that. For food plastic, mostly black plastic trays are used. I know you all have been going out to eat in the cafes or in the malls, mostly in the malls, mostly in the takeaways, and you all must have encountered that they give food in the black plastic trays. Why black plastic? Because black looks visually appealing. Food looks very good against the background, but this visual appeal comes at a very high cost of damage to the environment. Why? It will be clear to you very soon. Most of the plastics that enter municipal waste stream, such as polyethylene, which you normally called as polythene in our household terms, polyethylene tetraphthalate, that PET bottles, like the bottles of Coke, Pepsi, and whatever, and polystyrene and polypropylene. They can be recycled. Of course, they can be recycled, but there's a condition. The condition is that they must be first separated from all other materials in the household waste, and the plastics themselves to be sorted into separate channels. and with the minimum or no mixing of different materials. So as I was telling you that the problem, what is the problem? The problem is that recycling is not occurring at an ideal scenario as it should be. What is the current state of the art? Current state of the art is manual sorting. I don't know if any of you have visited any sorting facility in the municipality. I have visited one here in Copenhagen, and they have, the first is the manual sorting, then the size-based sorting, and then in the end, when the plastic is separated, to separate the plastic, they use NIR, near infrared spectroscopy, because NIR can detect all these types of plastics which I have mentioned, like polyethylene, PET, polystyrene, it can detect. So the first challenge is to separate different polymers into uniform and homogeneous streams. And the next challenge is to sort plastics that have been used previously for food and non-food applications and keep them apart. Only then the loop can be closed through recycling. I'm hearing some noises and it's kind of annoying.
Yes, participant, please mute. Participant, please mute yourself. Yeah.
Yeah, thank you.
Carry on, Rajat.
So, as I said, these are the two challenges. The first challenge is to separate different polymers into uniform and homogeneous streams. And the next challenge is to sort plastics that have been used previously for food and non-food applications and keep them apart. Why? Because I previously said, if you want a food tray, you want it that it was food tray in its previous life before it's recycled. It was not the part of some ammonia containing container. So, as I said already, the NIR is the state of the art. It can detect, it can identify different plastic polymers according to their absorbance at specific infrared wavelengths as they pass along the conveyor belt. But the PE, PET, PP, and PS, whatever I have mentioned till now, are used equally in both food and non-food applications. And NIR cannot distinguish between food and non-food applications. Furthermore, you must also keep this in mind that NIR cannot detect dark or black plastics in a waste stream. That's the biggest drawback of near infrared spectroscopy. So you need a solution which can identify the black plastic, which can identify between different kinds of plastics, which can identify the logos. Okay, why I'm talking about the logos? In Europe, there is a new law which has been introduced. It is called as Extended Producer Responsibility Law. If you are the producer of this particular type of black plastic, you are responsible for recycling it. This ensures the proper recycling. This also ensures that the black tray is not going into incineration or into landfills. So this law compels the producers to call back the plastic from the sorting facility and recycle on their own. So while we are talking about entrepreneurship opportunities, so you know what, you can always just take a look around wherever you are standing, and you will find an opportunity to do a business, such as these guys identified. In the next slide, I am going to show you how this solution works and how it identifies and sorts the black plastic. Also telling you that this market is huge. The global waste management equipment market, it was valued at euro 10.5 billion in 2018. And within this market, the robotic waste sorting equipment market is at 5.27 billion in 2019. And it is growing. In 2024, it is expected that it will reach 11.3 billion euros. There is a lot of money. Let's go to the next slide. And okay. So what is the solution to this problem? The solution is an AI-driven computer vision and robotic system. And this solution identifies all types of plastic packaging in a moving stream. It is specially designed for black plastic and food-grade plastic, including black plastic. And it identifies the plastic not just on the polymer types, not just based upon the polymer types, but also based upon the manufacturer to ensure the extended producer responsibility law, which I mentioned in my previous slide. By relying on computer vision, the system is able to identify and sort plastic objects from municipal waste, not just according to the polymer and color, but according to the product shape, bottle, tray. It can identify between bottle and a tray, an application, food and non-food. And that's why it enables closed loop recycling. Let's take a look at this short video and you will understand what I'm saying. Okay, so I will pause here and give you a brief about the system. As you can see that this is a robotic system, which is driven by computer vision and artificial intelligence. It has got an arm, which is sucking the black plastic and sorting it accordingly. So now you will have a clear idea what I was talking about in my previous slides and what the kind of opportunities we are discussing here. Of course, there is a very long road, and I'm 100% sure that Indian universities and Indian professors, Indian research scholars, students are capable enough, and we are already certified bright minds in the field of mathematics, computer science, electronics. So I see that we have a lot of potential to do something on these lines, so that we can solve our problems locally rather than relying on suppliers from abroad. Okay, so let's move on to the next case study. Oh, we still have the slide left. The solution, which I was just mentioning, as I said, that it's an AI-driven computer vision and robotic system. These guys had previous experience in postal sorting. They developed this AI algorithm to sort different posts coming from different cities of Denmark. And based upon, as you can see in this image here, based upon the type of posts, address, they sorted the post into different channels. And this experience helped them to develop this for the plastic sorting. So they have developed this computer vision algorithms for object detection, and the algorithm can read visual details such as patterns, embossed recycling symbols, barcodes, trademarks, logos, and brand names. I have been there personally in this sorting facility in Copenhagen. The video you just saw was made by me, by my phone, with the explicit permission from the client. And they are efficient. The system is good. It's beautiful. Okay, let's move on to the next case study, which is water waste. Okay, so you all must be aware of this water waste. We see this wastage every day in our lives, in our bathrooms. When we take a bath, we waste a lot of water. Of course, we say that this water is going into the drain, is going into the ground. But then again, it's not an efficient system. Ideally, it should be recycled properly. How? A company in Copenhagen has solved this problem. So the problem is water wastage. It's a household challenge. 11% of EU territory has a serious water scarcity problem. The problem is increasing. And we have this problem locally as well in India. I heard last that Bangalore was having this water problem, and groundwater level has gone drastically low, and people are struggling to get water, and they are calling water tankers. Of course, the water tankers, it's not a sustainable solution. We need to find a solution which is sustainable and which can go on for forever. Like, you cannot rely on your lakes to supply you with the water. So this water scarcity, this problem, showering is one of the biggest culprit. It accounts for 31% of household water use and is the second largest source of energy consumption in household. Of course, this energy consumption thing might not be that relevant for India, because in India, you don't take bath regularly with warm water, as opposed to Europe, where we need to take a bath like every day with warm water. We cannot take a bath with cold water. Right now it is -7 outside my home, and it's just way too cold to even to touch the water. So that's the reason water is the second largest source of energy consumption in household. There are some stats I have made available here for your kind reference. As you can see, it's a challenge. Water scarcity affects 3.6 billion people worldwide. So it's a worldwide problem. Okay, so after the challenge, let's see the solution. This company, this innovative SME, has developed the first retrofitable water recirculation shower. This innovative drain covers means shower is quick, cheap to install. There are the different parts like membrane pump, and then the stringent cleaning and efficient temperature control ensures great shower performance. The DTU, Denmark Technical University, took a test on this innovative shower technology, and then they found that the water quality is excellent because they are using ultraviolet cleaning, and they have back flush filter. So this is the kind of technology we need. It saves water up to 85%, energy up to 70%. Retrofit installation, that means that it can be installed in your existing washroom without any hassle. After 4,800 showers, it's free. It's free for you. And the cost of each shower is reduced by almost by 66%. So it's an excellent system for saving the water. So this was my second case study. I will move to my third case study, which is end-of-life tires. Have you ever wondered what happens to the tires when they have lived their life? What happens? Yes, you have seen those tires being burned. Is this a sustainable solution? No, I don't think so. It creates pollution. It creates a lot of other problems. So the recycling is the biggest challenge of end-of-life tires. I will call them for our ease, ELTs, end-of-life tires. They are amongst the most problematic and challenging source of solid waste. Yearly 1.5 billion tires reach the end of their useful lives, and then they potentially affect the environment. Hazards include soil contamination, landfill, overcrowding, and fire threat. What do we do with the ELTs? As I told you, that they are mostly burnt as cheap fuel to make cement or dry bricks. India is by far the biggest buyer of ELTs, accounting for 32% of global imports last year, and which was up from 7% 5 years ago. So that means we are on a growing trend. We are not like just stopping down. 7 years ago, we were 25%. Now we are like 32%. Once in India, these ELTs land, the tires are dispersed between legitimate recyclers who crump or chip the tire, the firms that burn them as cheap fuel to make cement or dry bricks, and increasingly to legal and illegal pyrolysis plants. So pyrolysis, this word came, and I will tell you about this. Pyrolysis is a new technology of burning the tire in the oxygen-less environment to create fuels. But pyrolysis is not as efficient as it should be. For this innovative company came up with an idea of a new solution where they can do a pyrolysis in a different way. And what they are doing is, okay, so as I said, that what is pyrolysis? Pyrolysis is a management route for ELTs due to its ability of obtaining valuable recycled products such as tire-derived oil, TDO. TDO is a word which you should keep in your mind. TDO is composed of a mixture of liquid hydrocarbons, nitrogen, sulfur, and oxygen in a large variety of complex molecular structures. Particularly sulfur concentrations here in the TDO ranges from 1 to 5 in compounds of thiols, sulfides, and disulfides, but also thiophanes, pentathiophane, and dibenzothiophane that are complex to remove due to their aromatic structure. And if these compounds like high sulfur and these aromatic structures are present in the TDO cannot be used as an alternative fuel. So state of the art, I told you, the pyrolysis is a coming up technology. Sometimes it is used in conjunction with distillation of heavy compounds. But this process, consecutive pyrolysis and distillation of heavy compounds, do not optimally remove volatiles, also ash contaminants and sulfur. So that limits its use in as a fuel and also its market value. What we can do here, we can design a pyrolysis process which is beyond state of the art and which can reduce the amount of sulfur and these volatiles, or if not remove, at least minimize, so that the value of the fuel increases. So this company, what it does, it sends tires through a pyrolytic reactor, and during the pyrolysis and chemical catalysis process, the hydrocarbon chains in the waste tires are broken to a different chain different chain lengths to produce combustible gas, a liquid hydrocarbon ash, and heat. The gas produced gets circled back into the fuel, the furnace. The liquid hydrocarbon goes through a refining process to clean and increase the value of the product, and the ash will be milled back into carbon black, a substitute from which the tire will be produced again. So that's the kind of closed loop recycling we are talking about here. I believe it's the perfect example of closed loop recycling. And that is the approach we have to take. We just cannot keep on burning tires, it's not sustainable. So you have to come up with such a solution where you are not just like getting rid of the end of life tire, a potential waste. You are also creating 3 different energy streams. And not to forget, so I'll just recap it for you. The gas which gets produced from the pyrolysis gets circled back into fuel the furnace. The furnace, it's a kind of self-sustainable system. The furnace will keep on burning from the gas which is produced from the pyrolysis which is taking place inside the furnace. The liquid hydrocarbon which gets produced goes through a refining process, becomes the fuel. The ash is milled back into carbon black, from which is a substitute for natural rubber, and from that tires are produced. And the heat which is produced from the system, it is the last but the most important. The heat will be used locally for either industry or heating of residential areas. So 4 streams, all 4 going into use. That's the kind of closed loop recycling the approach should be. Okay, so this was my 3rd case study. Let's move on to 5th one. The 5th case study is aquaculture waste. And what we are talking about here is fisheries. I assume that being from India, you are not that exposed to this aquaculture concept. Of course, there are some fisheries, some companies are coming up, but mostly in the coastal states of India, Karnataka, Maharashtra, where tilapia farming is taking place a lot because tilapia suits for tilapia breeding Indian ocean temperature and atmosphere, and the flora and fauna suits very well for tilapia. But it's not as huge as it's in Norway. Norway is a country which is the biggest producer of salmon. Salmon is a fish, and Norway is the biggest producer. And in this slide, in this image, you can see these are the sea farming cages. Here the salmon is farmed, and then sold to the market. So let's move on to the problem slide. What problem we are talking about here? The problem is that fishery waste and secondary raw materials. Fisheries is a resource intensive industry. And if you don't know, for growing the fish, for feeding the fish is used. Like you feed fish to grow fish. And that's why this is not very sustainable practice, because it's been going on since ages. Since the fishery started in Norway, they just know this method that you feed fish to grow fish. And as an estimate, 17% of total Norway fish production is used as the feed. So it's a big loss. You can come up with new ideas. You can come up with new feed ingredients to feed the fish, because at the end, what you need protein, you need some amino acids, you need some fatty acids, or whatever. I'm not a fish biologist, but yes, what the fish needs for its growth. So you can provide it from some other resources. I had a client from Norway. They developed this fungal-based, zygomycetes-based feed for the fish, and they are going superb. So this is the problem. This is the kind of problem I'm talking. Another problem is that when you're talking about fishery is, as I said, that it's a resource intensive industry, and the supply chain is huge. The upward supply chain and the downward supply chain, it's very long. Like you have a lot of suppliers, and then you talk to a lot of guys when you have your fish produced. I'll show you in the next slide what do I mean with this. And in this supply chain, each supplier uses their own legacy data system. And the problem with legacy data systems is that it's not shareable. Like you are a feed producer, okay, and I'm the guy who is running the cages. I'm the guy who is breeding the fish, and I need some feed from you. And the system which you are using for maintaining your data, your supplies, invoices, it's completely different. I don't have access to it. Of course, I'm not saying that you should give access to me, but there should be a way where we can interact, or at least our systems can interact and get to know, in order to reduce the wastage, in order to reduce the wastage of raw materials. In 2015, there was a report, I believe it was from Ellen MacArthur Foundation, and which was referenced by European Parliamentary Research. It estimates that by 2030, a shift towards circular economy. I'm just speaking it out of the context. It's not related to fisheries. It's related to the circular economy in general. That by 2030, a shift towards circular economy could reduce net resource spending in the EU by 600 billion euros. Bringing total benefits estimated at 1.8 trillion euros per year. This is the money you just cannot even imagine in your dreams. How many zeros are there? To unleash the benefits of the circular economy, it is necessary to foster the use of automated and easy to operate solutions. As I was speaking, that the legacy data system, it's not efficient. It should be changed. So we need that enable companies to discover new opportunities without disrupting their existing solutions. Most resource-intensive companies rely on different providers, as I already said, and their value and supply chains are such that when they deliver their products, they don't share their data. And that's why this company came up with this new solution. And the solution looks like this. It's a data integration and reuse across different supply chains tool. So our solution sits here in the middle, and the downward supply chain contains of feed producers, egg producers, fish farms, wastewater, restaurant handling, packaging, and the fish slaughtery. They all interact with our solution. like this is the downward supply chain. And here, once the product is ready, it needs energy, it needs logistics, it needs water, and it needs clients. So all these actors in this supply chain, in this fisheries operation, can interact with this solution. And this solution, what this solution does, okay, as I said, that this innovative company has developed a platform where the focus is on expanding the utilization of circular economy practices by the manufacturing industry, by improving data integration and reuse across different supply chains. This solution aims at improving how companies share their data and discovering new opportunities to reduce the environmental footprint. And it follows a twofold approach. It reduces not just CO2 emission footprints by finding new and cleaner suppliers. It finds new use for waste and secondary raw materials with lower footprint. So, as a result, in one of the pilot demonstrations, this SME demonstrated that a reduction in CO2 emission by 20% and consumption of primary raw material of 25% is possible. That is huge. It's just a pilot demonstration. Keep in mind, when it goes through large-scale demonstrations, when the technology is matured enough, and keep in mind as well that this company came to us for funding. That means that they are still at the developing or the evolving stage. Once they develop completely, when their solution is at TRL 9 or in the market, they can do wonders. So, and the solution is excellent. So the process, the process which enables this radical innovation consists of the following steps. I'll just walk you through how it works. So a company, say for example, a fish farm, registers in this solution and this platform and registers a new supply chain. It identifies its providers and adds the contact details of each company participating in its supply chain, including the type of data that each company must provide. In the second stage, supplying companies receive the invitation and register into the platform where the access to the supply chain will show up, and it will be prompted to provide access to its data sources associated to each supply chain where it participates. Once the company provides the location of the data, this solution, this company analyzes the data format and values and compares with its pre-existing plugins using its machine learning engine. So this term, machine learning, AI, will pop up at so many times because this is the trend, because this is the latest thing. The data science, what you have been hearing as well, is part of the science, machine learning and AI. And these technologies are the future, and they are shaping our future. And then this platform selects the plugins that maximizes the correlation and inform the company user through its data modeling interface with different scenarios. That, hey, there is a match with no modifications required. There is a match where some modifications are required, and then blah, 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 5 or 6 different scenarios. And once all the plugins for the different data sets are configured, the platform updates the central portal with the plugin description, with the data, to be able to link the data to similar information within the supply chain. And then I assume this might be taking a toll on you to understand it completely because it's a lot of info. So I don't want to give this data load on you. So all in all, what this solution does, it's just takes the data from all the suppliers and tries to match it with the, as I already said, to reduce the carbon footprint by finding the cleaner suppliers, and also reduces. Okay, I'll just give you a very simple example. This actor here, just let me go back. This actor here, the fish farm, or just go to the slaughtery. The slaughtery is where the fish is killed. The fish is slaughtered, and say for example, salmon is not sold as a full fish. Rather, it is sold in the form of fillets, and the fillets are where there are no bones and just a piece of meat, which can be you can just grill it, salt it, and eat it. And in this process, a lot of waste is generated. Say, for example, gills, skin, scales, all this comes out. All this contains nutrition, and this can go back to the fish farm for feeding the fish. Rather than you feed the whole fish to the fish, you feed the waste coming from the slaughtery to the fish. Previously, the slaughtery was just throwing away this waste, and there was no application of this waste. There was no use of this waste. But with this solution, the fish farm knows that slaughtery has generated 200 kgs of waste, which if I buy at a very lower cost, I can feed it to my fish, and then I'll improve my margins, I'll improve my profits. So this is the kind of example scenario I believe with which you'll be able to understand what I'm talking about here is. Okay, so this was the fourth case study. Moving on to the fifth one. The fifth case study is industrial heat wastage. Industries, big industries, they produce a lot of heat. You must have been hearing these days that Google data center is beneath the ocean. Why? Because Google servers are, okay, you have a computer in your home, it generates a lot of heat from the backside. If you just go place your hand on the backside of your CPU, you will see a lot of heat coming out of it. Just imagine what if 10,000s of such CPUs exist in one location. The just unimaginable amount of heat generates from there. So Google has submerged I'm not sure if it's Google or Facebook, but they have submerged their data centers beneath the ocean to cope up with this problem of cooling the servers. So that's the kind of heat big industries can produce. So, and it's just common in all the industries. How we can use that heat, how we can reuse the heat coming out of the industries. So the problem is that when you burn the fossil fuels in the for operating the industries, for heating, you are wasting a non-renewable energy source. And this way and the energy which cannot be recovered, CO2 gets produced, which is not cost efficient and neither it is environment friendly. European Commission has set some very ambitious targets. By 2030, they want to cut the greenhouse gas emissions by 40%. They want to increase the share of renewables to 32%, and 32.5% increase in energy efficiency they are looking forward to. Denmark, on the other side, has even more ambitious targets. By 2030, Denmark wants to cut the greenhouse gas emission by 50%. I don't know if you know, but Denmark is one of the biggest producers of windmills. The Vestas is a company which installs the windmills across the world. In India, I think a majority of these windmills are from this Danish company, Vestas. So this is the kind of problem we are talking about here, and the solution is an innovative heat pump. So this SME has developed a groundbreaking, innovative, smart, industrial, high temperature heat pump solution. The solution is based on a reverse Stirling engine that uses helium as working medium. And this solution represents a radically low impact, cost efficient technology. This pump generates high temperature stream from low temperature waste heat, providing temperature lifts of 10 to 150 degrees Celsius. Heat pumps are a common thing in the market. It's not that this company has made something entirely new. What they have done is they have gone beyond the state of the art. They have changed how the heat pump works. Because the heat pumps which are in the market, they operate at slightly lower temperatures below 150, and that's the reason like the companies or the customers, they are a bit reluctant, because there are some applications where constantly more than 150 degrees Celsius of temperature is required. So compared to the heat pumps on the market, which is, as I said, that they are already there, this particular pump is unique, that it can deliver hot water or hot steam of up to 200 degrees Celsius. This pump delivers a superb operational efficiency for both high temperature demand and combined heating as well as cooling applications. So this company did a pilot study, a demonstration study, and there they have shown that this pump reduces total fuel demand by 2,300 megawatts versus gas boilers to meet annual 180 degrees Celsius stream demand for industrial users. And what it does, that, as I said that already, it receives heat from a waste stream from the industry, and this heat stream which it receives, it's of lower temperature. It extracts and increases the heat from waste source and delivers useful heat. So, and on this similar testing, what they performed, they showed that this industrial user can save 33% in cooling cost, equal to 36, which is equal to 36, roughly, I believe, 36,000 euros per year. Yes. So this is the kind of solution we are talking about here. So all in all, I had 5 case studies of cutting-edge innovative SMEs across Europe. And they showed you how you can recycle the different kind of wastes, how you can enable the closed loop. It's not just about the recycling, it's about the closed loop recycling, which is the most new concept, and we should be focusing on that rather than recycling. So I believe this was useful to you. This was an interesting session for you, and
of course, Rajat.
Thank you very much for listening. Thank you, Vikas.
Very insightful talk, and we get to know so many innovative talks, innovative model that you have presented into different sector. Now I would like to invite participant to ask any question if they will wish to ask. Participants, if you have any question, you may ask directly to Dr. Rajat. Anyone? Yes, Rajat, I would like to have a question for you.
Mm-hmm.
Seeing some innovative models that you have presented, these are directly related with the research organizations, or some industrial corporates are going to work onto those?
No, so these case studies are from the companies, from the innovative SMEs, small and medium enterprises, and they have this. They own the IP. There are no universities involved in this. Of course, universities are involved when we do some large-scale consortium-based research projects. But then, in the end, the IP belong to the companies, to the private organizations, not to the universities.
And there's one more question, that if the solutions that you have talked about, if it is equally applicable to India or not?
Why not? India has the similar problems. In fact, the entire world has the same problems. If you talk about the plastic, the water, industrial heat, fishery might not be that relevant for India, but still, because I selected these use cases, these companies based upon Indian scenario. So I could have selected anything which is not directly relevant to India, but then that was not the case, because I'm talking here to Indian audiences. So what about the cost involved? Would you be more explicit and talk to me in on audio?
Would you like to interact directly? You may interact directly to sir about your question.
Good evening, sir. Dr. Manishita Mukherjee this side. Sir, I agree that the solutions might be viable for India, but what I am more concerned about is that are they economically feasible?
Why not? Economically feasible, you mean to say that the cost of the solution?
Yes, sir.
Okay. So,
So firstly, the cost of the solution, and secondly, so the waste generators, are they ready to pay the cost for the solution? That is also another big question for a country like ours.
first of all, waste generators are not going to pay for this. It's the government who is going to pay for it, because the waste sorting facility is controlled by the government, by the municipalities, and they are going to pay for it. Of course, the cost involved, what we are talking about here, it's on an Indian, if we compare it with the Indian standards, it is way too high. But it is just because it is Europe, and that too in this is Scandinavia, where the labor costs are just sky touching. But if you try to build the same solution or similar solution in India, definitely you can do it at a much lower cost. And based upon the cost involved in manufacturing, in producing the solution, you can easily set the cost of the solution at a price which is affordable by the government or by the municipalities. But
Yes,
see, I would just like to I would like to clarify more. There is no rocket science involved. There are some basic computer
of
vision,
course.
artificial intelligence algorithms. We are already doing it. We have a lot of researchers from India. I know personally a lot of them who are involved in doing this AI and machine learning things. And after that, what you need, if you take the example of that robotic sorting solution, what it has just got a robotic arm, a camera, a 4K camera, and a computer. All the components are off the shelf, which you can buy just by going to the right place and getting the off-the-shelf component, build up into a robot, infuse the artificial intelligence algorithm, and just start working. There is no rocket science involved.
Very rightly said. And now, if any
Yes, sir.
participants are there who want to ask, any participants want to ask questions? I guess it's end of the day for the session now. So thanks a lot, Dr. Rajat, for accepting our invitation and presenting your such an innovative, insightful talk to all the participants present here. And I am confident enough that the 360-degree approach that we had adopted in presenting different sessions are really wonderful and going great to help them in future as well. Thanks a lot again for joining us. Thanks a lot.
Thank you, Vikas, and thank you all.
Okay, participants will be having a tomorrow session as scheduled on the same link. Thank you. Thanks for joining us.